Now, the final example in the textbook for partial fractions is this one. And I really do think it goes a little bit beyond simple cases. That was the wording used in the syllabus. I'm going to come back to that after I've walked you through this example. It says, demonstrate that this rational function is equal to this, and hence determine the integral. Well, in this case, they've actually told you what that rational function equals in a form that you can then integrate. But if it didn't, you could obtain this yourself. And one of the ways that we're going to look at for how you demonstrate that these are equal is the way that you can use to in fact work out this equivalence. But it's really complex, not simple. Let me show you. So the first approach is just to try to start with what they've provided, and I actually think this is probably the simplest way if you are given the equivalence. This is kind of a whole and fractional part version. So what you can do is fraction addition. You multiply the 2x plus 1 by the x squared minus 4, and then you add those as numerators with the same denominator. So if you expand that out, you get this, minus x plus 10, and then if you work through that, you'll get this, which is what we started with. Now this way works, and I do think it is the simplest, if you are provided with this expression. But if instead it just said integrate this horrible complex thing, then you would instead have to do the division yourself. Now that's not impossible. It's a little tricky in this case because they've got x squared minus 4, which has an invisible 0x term, which you have to remember when you do the long division. So you do the long division, you write this out, include that middle term and the numerator you're trying to divide it into, and then you go, well, x squared into 2x cubed goes 2x times. I personally write the 2x above here. Then you go, well, that's 2x cubed, and you work through, it's 0x, becomes 0x squared, and minus 4. So you have to work it with 3 terms at a time. Do that. Do it again with this next one. What you're left with here is, in some sense, smaller. It's less complex than this, so you can't go any further. And therefore, the numerator you had and the denominator you had are equal to this quotient plus this remainder as a fraction over the denominator. So, again, if you're provided with what it should look like, I think this is probably the least error-prone way of doing it. But if they only give you an expression and you have to work it out, you will have to do the long division yourself. Having done so, we go back to what we've just been practicing before. We write the fraction part and we express it as a partial fraction, because this of course is x plus 2x minus 2. It's a difference of 2 squares. Write it as partial fractions, solve the partial fractions, work out what that's equal to. Then of course you can integrate the thing you started with in 2 parts. The 2x plus 1 is relatively easy, and then you have 2 partial fractions which each become a log. So that's the method.